All right, number 12. The picture shows water boiling in a pan on a gas burner. Here I've got the letter A pointing to this arrow, the letter B pointing to this arrow, the letter C pointing to the pan. Okay, so number 12, where does convection, so you want to highlight convection, occur when you are boiling water? So at point A, at point B, at point C are your options, 1, 2, and 3. So at A only is answer choice A. Answer choice B is at B only. Answer choice C is A and C. And answer choice D is A and B. So, what is your best diagram for showing convection? Convection. Number 13. Lath notices that the air in his science class is warmer than the air in his math class. Which statement describes how the air particles are different in his colder math class? So we're talking about the colder room here. Are they vibrating? Are they moving more freely? Are they moving faster? Or do they have less average energy? So vibrating more freely, faster, or less energy. Which is true about the air particles in the colder math classroom? Number 14. While on vacation, Corrine rides in a hot air balloon. To make the balloon rise, the pilot turns on a flame to warm the air inside the balloon. How does the air change? So, we're looking at warming the air. How does that change the air? The temperature of the air decreases. So we have temperature decreases. The air particles move closer together. The motion of the air particles increases. Or the air changes to a different state of matter. Okay, so when you warm the air, is it a temperature decrease, moving the particles closer together, a motion increase, or changing to a different state of matter? Number 15. Students put the same amount of water into 4 beakers and warm them to 60 degrees Celsius. They then place each beaker in different locations in the classroom. After 5 minutes, the students measure the temperature of each beaker of water. The results are shown in the bar graph below. At which location do the particles of water move the slowest after 5 minutes? So we're looking for the slowest moving particles. So does slowest mean the hottest or the coldest or somewhere in between? So after 5 minutes, we have on the teacher's desk that's looking to me at about 40, a little over 43 degrees Celsius. By the window, a little over 45. Near the door, right at 42. Or in the back corner at 38. So where are my slowest moving particles? A is near the back door. B is by the window. C is in the back corner. And D is on the desk. So, what are the slowest moving particles? Number 16. Solar energy passes through the solar panel on this calculator to make it work. Which energy transformation is taking place? Radiant to electrical, electrical to chemical, nuclear to thermal, or mechanical to radiant? What are we looking at in the solar calculator there? Number 17. When a handheld fan is turned on, the blades spin. Which diagram shows the energy conversion that is required to make the fan work? So it's a handheld fan, like the ones in our lab, that are worked by batteries. So we have batteries that are making the fan move. Is that electrical to chemical to light? Electrical to chemical to kinetic? Chemical to electrical to light? Chemical to electrical to kinetic? Okay, and I will tell you that if you're using the word kinetic here, we're going to substitute that for mechanical. Okay, so kinetic equals mechanical on that one. I can even... All right, so kinetic equals mechanical. So that, hopefully that'll help you a little bit. So we're looking at the batteries to, that make the fan work. What kind of energy transformation is that? Okay. All right, number 18. Mark places new batteries in his portable Blu-ray player and turns it on. Identify the correct energy transformation. So a portable Blu-ray player is like a little mini TV, okay? We have batteries, and then he turns it on. So we have electrical to chemical to mechanical and sound, chemical to electrical to mechanical and sound, sound to chemical to mechanical and electrical, mechanical to chemical to electrical and sound. So really, there's only one answer choice that correctly identifies batteries, okay, where we start. So if you know what batteries are, then you can get the correct answer choice pretty quickly. But if you're not sure, think about, what happens next and what happens next. So hopefully that helps. All right, number 19. Below is a diagram that shows how a hydroelectric dam uses water to produce the electricity to light our homes and schools. Which list below shows the correct order as energy moves through the dam to a house? So we're starting here, we're going here, we're going here, up to here, and that way to the house, okay? So you can kind of see the arrows there. Okay, so is that the generator to the turbine to the electrical light? Is it to the electrical light? Does it start at the electrical light, go to the turbine, and then the generator? Does it start at the dam, then the turbine, then the electrical light, and then the generator? Or the dam, and then the turbine, and then the generator, and then the electrical light? Which is the correct order from start to finish? Number 20. Which device transforms electrical energy into mechanical energy? So again, if I were you, I'd just go ahead and write out the energy transformations on each one and see if you have an electrical to mechanical. And choose that one if so. If you have more than one, then you made a mistake. If you have less than one, then you made a mistake. So go back and look. All right. finally, you have a numeric response on this one. So you're going to bubble your response and read this one really carefully. It's kind of easy to make a silly mistake, so be careful. Look at the table provided. Water at 40 degrees was placed into containers made of 4 different materials. An initial temperature was taken and a final temperature was taken after 10 minutes. How much did the temperature change in degrees Celsius during the experiment for the container that allowed the most transfer of energy, of thermal energy? So we're looking for the one that had the biggest transfer, okay? And what was the total change in temperature on that one, okay? So we start out with 40 on all of them, and then we end up with 32, 18, 30, and 28 degrees respectively. So where is the most thermal energy transfer change, and then what is the difference? Okay, so you're finding the difference and recording that, the difference from the original temperature. So the total change, okay? So hopefully that'll help.